Hello students, welcome to my channel. If you are new to my channel, don't forget to subscribe my channel. You will get the alerts about my classes. Okay. So today I am going to explain you about the shortcuts to solve a pulley problem in rotatory motion. So you might have seen Atwood machine in Newton's laws of motion where we have derived the acceleration formula of the system. Now here it is also same, but what is the difference I am going to tell you. Let us consider M1 M2 are the two blocks which are connected by means of a massless string and passed over a pulley of moment of inertia I and radius R here. Okay, now let us consider M2 greater than M1 so that the system has an acceleration, that is M2 is going down with an acceleration A and M1 is going up with an acceleration A. Let T1, T2 be the tensions in the strings here. So if you observe the pulley system Atwood machine in a Newton laws of motion, we have taken T1 equal to T2 there by assuming that what we have done here, the blocks, the string slides over the pulley, but pulley does not rotate. But here the pulley has to rotate. If the pulley has to rotate, if the two tensions are same, what is the net force acting on the pulley? Net force will be 0. If the net force is 0, net torque also 0 and the pulley is not going to rotate. So therefore we have taken the two different tensions so that the pulley rotates and the blocks will have acceleration A. Let us write the equations of motion for M1, M2 and this pulley here. For M1 first I am writing because tension is more than weight here. So I can write T1 minus M1G equal to M1A. This is I am calling as equation 1. And for second block M2, if I write this, M2 is more than tension. So I can write M2G minus T2 equal to M2A. This is equation number 2 I am calling. And what about this pulley here? Pulley is rotating. For rotation, what is required here? The torque is required, and torque formula is tau equal to, we can write I alpha, and tau equal to, we can write force into net force into perpendicular distance from axis of rotation, and alpha equal to, we can write A by R because the relation between alpha and A is like this here. Okay, so let us substitute what is the net force acting here. As T2 is greater than T1, I am writing T2 minus T1 into perpendicular distance is R equal to IA by R. So bring this R to the right side so that it becomes what here, T2 minus T1 is equal to IA by R square. Call this as equation number 3. Now we have three equations 1, 2, 3. Add them. If you add, what happens here? You can see T1, T2, T3. T1, T2. Here T1 is positive. Here it is negative. Here it is negative. Here is positive. So the two gets cancelled out. What is left here? M2G and M minus M1G. So take G common. So M2 minus M1 of G equal to, left side we have M1A, M2A and IA by R square. So we can take A common. So M1 plus M2 plus I by R square of A. Now we want the acceleration of the system. So I am writing the same. A equal to, therefore what we get here, M2 minus M1 of G divided by M1 plus M2 plus I by R square. So if you recollect your knowledge about acceleration of the Atwood machine, so what is that here? That is A equal to, if you remember, M2 minus M1 of G divided by M1 plus M2, net force by total mass. Here also the net force is same, but the total mass is including pulley we have taken, that is I by R square represents what here? Mass of the pulley here. Okay, so this is acceleration of the system. If you substitute this value in equation 1 and 2, you are going to get the tensions in the string here. So same I am writing. Equation 1 is what here? Equation 1 is T1 minus M1G equal to m1a. Bring to right side and substitute the value of a, m1, and a value I am writing m2 minus m1g divided by m1 plus m2 plus I by r square, plus what is there, this m1g comes to right side, becomes m1g plus what we can take common, we can take m1 is here, g is here, so we can take m1g common. So I am writing m1g common, and what is the LCM here? LCM is m1 plus m2 plus I by r square. So here this as it is, we are going to get m2 minus m1 in the numerator of this one, plus what is there, this denominator comes as m1 plus m2 plus I by r square. So if you observe, minus m1 plus m1 cancel out, we are going to get t1 as m2 and m2 becomes what here, 2m2 plus I by r square plus m1g divided by m1 plus m2 plus I by r square. If you recollect your knowledge about tension in Atwood machine, that was like this, that is T1 equal to 2m1 m2g by m1 plus m2. Okay, so because the I by r square extra term coming here, that is what here, mass of the pulley here. Okay, now to get T2, we have equation 2 here. The equation 2 is what here, m2g minus T2 equal to m2a. So T2 equal to m2g minus m2 of the equation, that is m2 minus m1 of g divided by m1 plus m2 plus I by r square, that is acceleration of the system. So what is a common term here? m2g is there, m2 is there, g is there. So I am taking common, that is m2g common. And what is the LCM of the system? LCM is m1 plus m2 plus I by r square. And here we are left with what here, this 1, and this denominator comes here. So I can write m1 plus m2 plus I by r square, and minus of m2, minus into minus plus m1. Okay, so here minus m2 plus m2 gets cancelled out, m1 becomes 2m1. So the equation of this T2 becomes here 2m1 plus I by r square, because m1 2m1, I by r square is left. Denominator is m1 plus m2 plus I by r square, and multiplication is m2g. So this is the T2 here. If you observe, there is a difference between T1 and T2, but if I by r square is not there, then T1 also becomes T2, T1 becomes equal. Okay, so this is the tension in the string. Once again I am repeating what I said here. We have taken a system of two blocks m1 m2 connected by a string passed over a pulley of moment of inertia I, radius r, and you know this m2 greater than m1 we assumed, so that m2 goes down with acceleration a, m1 goes up with acceleration a, and tensions in the strings are T1 and T2. We wrote the equations of motion for first one and second one, that is equation 1, equation 2, and for pulley the T1 and T2 must be different, then only there is a net force acting on the pulley which makes the pulley to rotate here. So net torque we want to calculate. So net force is T2 minus T1. Torque means force into perpendicular distance. Here r is the perpendicular distance. So T2 minus T1 of r equal to I alpha, where alpha equal to a by r we substituted. So T2 minus T1 equal to, we got I a by r square. By adding those three equations we have arrived the expression for acceleration. So this is acceleration here, similar to Atwood machine, but extra term is I by r square. Substituting in equation 1 we got the expression for tension T1 as well as T2 while substituting in equation 2 here. So I hope you understand this concept. So don't forget to subscribe my channel. and wait for my future classes. Thank you.